All right, so what we have here is we have 3x cubed minus 2x squared minus 150 being divided by x minus 4. So I'm going to set up this long division, and don't worry too much about this because I'm going to show you a lot easier way to handle these division problems you have to do after we do this. I think mainly we just go through this again so that you appreciate synthetic division when we get to it. So first, when I'm setting up this divisor underneath the bracket that I've got here, I need to look and see what degree this divisor or this dividend is. And it is of degree 3. You can see the highest power of x that we have there is that 3. So I need to make sure every power of x down from that is represented. So you see the 3 right there, you see the 2. I don't have a 1. So I'm going to have to put that in. I'm going to have to put that placeholder in when I write my dividend under the bracket. So 3x cubed minus 2x squared, and then plus 0x minus 150. And then our divisor stays outside. Now, when I am starting to divide, I'm just going to look at the first term in my divisor, the guy outside, and divide that into the first term in my dividend, the thing under the bracket. So x goes into 3x cubed. How many times? 3x squared times. So let's write that down. Write that over the x squared term there. So now I'm going to take that and I'm going to multiply, just like when you do long division with regular numbers without all these x's and everything going on. So I'm going to multiply, but I'm going to multiply by both the terms in this divisor that I have. So 3x squared times x is 3x cubed. 3x squared times minus 4 is minus 12x squared. Remember that we are subtracting in this step, so I'm subtracting that whole thing. Well, 3x cubed minus 3x cubed is nothing. Negative 2x squared minus negative 12x squared gives me positive 10x squared. And then my next term that I'm bringing down is this plus 0x. All right, now I'm going to take, my next step is I have to divide again. I'm going to take that x, that's the first term in my divisor, and I'm going to divide it into that 10x squared. I'm just looking at the first term. So x goes into 10x squared, positive 10x times. 10x times x gives me 10x squared. So now my next step again is to multiply. Remember, I'm going to be multiplying both things in my divisor. So 10x times x gives me 10x squared. And then 10x times negative 4 is minus 40x. And I hope I don't run out of room here. So my next step here is to subtract. So 10x squared minus 10x squared, well, that's easy. That's just nothing. And then 0x minus negative 40x should give me positive 40x. And I'm bringing down, luckily, my last term here, 150. All right, so now I'm going to look at that x, that first term in my divisor. How many times does it go into 40x? Should be plus 40. And my next step is, of course, to multiply. So I'm going to be taking away 40x, and then 40 times negative 4 is negative 160. 40x minus 40x is 0. Negative 150 minus negative 160 gives me 10. And that's it. I don't have anything else to bring down. I can't divide anymore. I'm done. So that 10 represents my remainder. So my answer then to this whole thing if I'm looking at this, I had 3x cubed minus 2x squared minus 150 divided by x minus 4. The answer is 3x squared plus 10x plus 40, and then our remainder was 10. So it's positive. And 10 parts left out of what we're trying to take out, x minus 4. So that is my answer. All right. So let's look at this again, but I promised you what I think is an easier way to keep track of all this and do it. So let's see how to do that. I still have the same exact problem. I have this 3x cubed minus 2x squared minus 150 being divided by x minus 4. This time I'm just going to be looking at the constant. And I'm just going to be looking at the constants in front of my x term. You remember our first step is always check to see if you need any placeholders. Check to see if you need placeholders. So this is degree 3, so I have to make sure everything from 3 down is then represented. So x to the third, well, yeah, it's degree 3. So x to the second, yep. X to the 1, no, I don't have anything. So I'll have to put a placeholder in for that. So this time I'm going to draw the bracket upside down. And I'm just going to take the coefficients. So I have 3x to the third, negative 2x squared, 0x, and then I'm going to put the constant in there, 150. So to do this type of division, the first thing you want to do is just bring that lead coefficient straight down. The next step is to multiply. 4 times 3 is 12. This time we are adding, you are not subtracting. Negative 2 plus 12 is 10. Your next step is to multiply. 4 times 10 is 40. Remember that we're adding. 0 plus 40 is 40. Your next step is to multiply. 4 times 40, 4 times 40 is 160. And remember that we are adding. So negative 150 plus 160 is 10. So when this is, you're almost at your answer. This is your remainder. Whatever comes last is your remainder. Then your constant, as we go this time right to left. So remainder, constant, then your first power of x. So that's x to the 1, then your next power of x, x squared. So let me write down the whole problem. 3x cubed minus 2x squared minus 150 divided by x minus 4 is equal to 3x squared plus 10x plus 40 is our constant. My remainder is 10, it's positive, so plus 10. And you'll remember my divisor was x minus 4. You can only use this synthetic division if your divisor is a binomial with x being degree 1. Okay. The remainder theorem states that if you have a polynomial, it's a function of x, and it is being divided by x minus k, then the remainder is equal to the function of k. So with that in mind, if we're looking at this was being divided by x minus 4. So in that k position would be the number 4. My remainder is 10. That tells me, that remainder theorem tells me that the function of 4, when I'm looking at this function, 3x cubed minus 2x squared minus 150, the function of 4 is 10. All right, so if the function of x is that function we just looked at, 3x cubed minus 2x squared minus 150, then by the remainder theorem, the function of 4 is equal to 10. Because when I divided that function by x minus 4, I got that remainder of 10. And you can put a 4 in everywhere you see an x, and you can solve, and you will in fact get 10. Let's look at this one. I have 4x to the third minus 15x squared plus 11x minus 10. I am dividing by x minus 3. So your divisor, the thing you're dividing by, needs to be in this x minus k form. In the k position here, we have 3. So I don't have to take the additive inverse because my binomial has that subtraction sign, not addition. We'll look at one where it's addition, and we do. But for right now, you don't have to worry about that. So I need to look at my dividend, the thing that I'm dividing, and my first question always is, do I need to put in any placeholders? Well, what degree is this? If you look, you see the highest power of x up there is 3. So count backwards, see if everything counting backwards is represented. So 3, I see, obviously it's degree 3. So 3, 2, 1. Yep, you got everything. Don't need a placeholder. So I'm going to leave that 3 outside. I'm going to draw my bracket upside down. And then I'm just going to take those coefficients. We already looked, we don't need a placeholder. So I have 4, negative 15, 11, negative 10. All right, so first step, bring down the first number. So 4 just goes straight down. Next step, multiply. 4 times 3 is 12. Next step, add. Negative 15 plus 12, negative 3. Next step, multiply. 3 times negative 3, negative 9. Next step, add. 11 plus negative 9 is 2. Next step, multiply. 3 times 2 is 6. Next step, add. You will get negative 4. So that's it. So now you need to figure out how to write your answer. So start at the right and go left, the opposite way that we read. Remainder, then constant, then x to the 1, then x squared. Do you see how the highest power of x we're going to end up with in our answer is x to the second power? If you look at the function that we divided, It is of degree 3. So the highest power we have up there is x to the third. So we should come out with 1 less than that. 2 is 1 less than 3. So we are definitely on the right track. So the way I would write this answer then is 4x squared minus 3x plus 2. My remainder is this negative 4, so minus 4, and then your divisor was x minus 3. And that's it. And you can also, at this point, if you remember the remainder theorem, which you might not because you just learned it 5 minutes ago, if you look at this problem, you should be able to tell me, without substituting anything in, what is the function of 3? Oh, must be negative 4 because that's the remainder. So the function of 3, when it comes to this function that we just divided, is equal to negative 4 by the remainder theorem. All right, let's look at this one. I have negative 3x to the fourth plus 2x to the third minus 6x squared minus 5x plus 3, all being divided by the binomial x plus 2. So I want to use my synthetic division, but you remember that your divisor needs to be written in this x minus k form. So the way I would then put a number in that k position to fulfill those circumstances would be x minus negative 2. So negative 2 is what is going to be staying outside. What degree is our dividend, the function that we're dividing? It's degree 4. So I want to see, do I need a placeholder? So I'm going to count backwards from 4. So I have 4, 3, 2, 1. I don't need a placeholder. So I can go ahead and put those coefficients in. So I have negative 3, positive 2, negative 6, negative 5, and 3 is my constant. So first step, negative 3 comes straight down. Negative 2 times negative 3 is positive 6. I want to add 2 plus 6 is 8. Next step, multiply. Negative 2 times 8 is negative 16. Negative 6 plus negative 16 is negative 22. Negative 22 times negative 2 is positive 44. And then I want to add negative 5 plus 44 is 39. And then I want to multiply. Negative 2 times 39 is negative 78. Extend that a little. 3 plus negative 78 is 75. So that's my remainder. Then I want to start at the right and go left. So I have remainder, constant, x squared, x to the third. I'm ending up with my highest power and my answer being 3, and that's 1 less than in my original function that I divided, so that's good. So I get negative 3x to the third plus 8x squared minus 22x plus 39. Then I have this remainder. It's positive, so plus 75. My divisor was x plus 2. And I also should know the function now of negative 2. And it is 75. All right, let's look at this one. I have x to the fourth minus 1 being divided by x minus 1. So my divisor is already in that form of x minus a number, so I don't have to worry about taking the additive inverse, switching signs or anything. So I'm just going to have 1 outside. Do I need a placeholder? For sure I do. I see that this is x to the fourth, so this is degree 4. I don't have any x to the third. I don't have any x to the second, any x. So yeah, I'm going to need a placeholder. So I have 1 x to the fourth, no x to the third, no x to the second, no x, and then minus 1. All right, so now everything is just like we've been doing. That 1 comes straight down. My next step is multiply. 1 times 1 is 1. My next step is to add. 0 plus 1 is 1. 1 times 1 again is 1. Add, you get 1. 1 times 1 is 1. Add, you get 1. 1 times 1 is 1. And look what happens here. 0. Huh. All right. So remainder, constant, x squared, x to the third. All right. So this is going to be x to the third, 1x to the third and x to the third are the same thing, plus x squared, plus x, plus 1, and no remainder. So that tells me my original divisor is x minus 1. So x minus 1 times this thing, x to the third plus x squared plus x plus 1 would give me x to the fourth minus 1. And it also tells me if I can still use the remainder theorem, 0 is a number, my remainder is 0, that tells me that the function of 1 is equal to 0. So 1 is a 0 of this function, x to the fourth minus 1. Whenever you put a 1 in, it will in fact be equal to 0. And you can even pretty easily see that. All right, here I want to use the remainder theorem to find the function of 4. So that means I'm going to set up this division, and I'm going to leave what outside, do you think? See if you can beat me to it. Even if you're not sitting in class, you should still be writing and taking notes. So I'm going to be leaving that 4 outside. I need to look at my function, see do I need any placeholders. I can already see I do. So this is a function of degree 4. So this is 4, 3. I don't have a 2. So 1 I do have. So I have 0 x squared. I need to make sure that I represent that when I put everything in here. So -3, positive 15, no x squared, get that placeholder in there, minus 50, 25. All right. So the first number comes straight down, -3. Then I multiply, -12. Then I add, +3. Then I multiply, 12, add, I get 12. Here I get +48, so -2. 4 times -2 is -8. When I do that addition, that last addition, I get 25 plus -8, that gives me 17. 17 is my remainder, so that tells me the function of 4, when this is my function, -3x to the fourth plus 15x third minus 50x plus 25, when that's my function, the function of 4 is equal to 17. So if we just get a function and I want to start looking for what might be some possible zeros, and it looks hard to factor. We don't know how to factor this. It's degree 3, that's hard. We can use the rational zeros theorem. So the rational zero theorem says if you have some rational number and it's a zero of the function, the top part of it is going to be a factor of whatever the constant in your function is. And the bottom part is going to be a factor of the leading coefficient. So the leading coefficient is just the number that's in front of the highest power of x. So the constant here is 18, and the leading coefficient is 2. So I want to know, is 2 a zero of this function? Well, I can just use synthetic division really quickly, and I can see if 2 is a zero of the function. And then I can see, does it fill that rational zeros thing we're talking about now? So we're going to leave 2 outside. Do I need any placeholders? 3, 2, 1. I have no just plain x, so yeah, I do need a placeholder here. So 2, -3, 0, -18. Okay. No, it is not a 0. Okay, so this is just the function that was on the last slide there, but I was kind of running out of space. So my rational zeros theorem that we're talking about now tells me that any zeros of this function can be looking like this. So P over Q. P is a factor here, and Q comes from a factor of our lead coefficient. So for 45, I have all these factors. I have positive, -1, positive, -45. This positive and negative is applying to everything. 3, 15, 9, and 5. And then our lead coefficient is just 1. Let's make sure that looks right. All right, 1. So my factors of 1 are positive and -1. So possible zeros then are positive, -1, positive, -45, 45 over 1, positive, -3, positive, -15, positive, -9, and positive, -5. So that wasn't too hard because our lead coefficient was 1. So you didn't really have to do any division there. So one of the possible zeros that we came up with was positive or -3. So let's try 3. Let's see if 3 is a zero of this function. And we're going to use synthetic division to test it. So 3, 4, 3, 2, 1. I don't need any placeholders. So 1, -4, -14, 36, 45. And I want to know is 3 a 0. So I'm just going to use my synthetic division. So 1 comes straight down. I multiply. I add. 3 times -17 is -51. When I add there, I get -15. Look at what happens. 3 times -15 is -45. 0. So 0 remainder means 3 is in fact a 0 of this function. So yeah. So that tells me 3 is a 0 3 is a 0, and that means the quantity of x minus 3 is a factor. If I put 3 in there where I see an x, I would get 3 minus 3. That would go to 0. I would have 0 as a factor. The whole function would go to 0. So that makes sense. So let's say I get this function, and I want to look for some possible zeros. I don't want to try to start to factor this just blindly. It would be way too complicated. So what I'm going to do is I'm going to use that rational zeros theorem. I know that zeros will be able to be written in this P over Q form, and I know that P is going to be a factor of the constant, and I know Q is going to be a factor of the lead coefficient. So my constant is 2. My lead coefficient is 6. So for P, my factors are positive and negative 1 and 2. Good old 2, lowest prime number. Only even prime number. All right. And then for Q, my lead coefficient is 6. So I get positive, negative 1, 6, 2, and 3. And that's it. That's all the factors of 6. So if I'm looking at that, I'm thinking of all the different ways P over Q could happen. And you can get any combination of positive, negative. So everything's going to have positive, negative. I'm going to get positive, negative 1, positive, negative 2, positive, negative 1/3, positive, negative 2/3. I don't have to do 2 over 2 because I already have 1 over 1. That simplifies to the same thing. Positive, negative 1/2, positive, negative 1/6, and I think, yeah, that's it. So there, that's not saying those are all zeros of that function. That's saying, look there, these are the possible zeros. So if I look at that, 1 is nice and easy. It's a nice whole number. So let's just see if 1 works. Let's see if 1 is a 0. So looking at our original function, do I need any placeholders? It's degree 4. I have everything represented. 4, 3, 2, 1. I'm good. So I want to write 6, 7, negative 12, negative 3, and 2. Is that right? Yeah. All right, the 6 comes straight down, then we multiply. 1 times 6 is 6, then we add 13, then we multiply. 1 times 13 is 13, negative 12 plus 13, I'm adding now, is positive 1. 1 times 1 is 1. Negative 3 plus 1, negative 2. Look at that. 1 times negative 2, negative 2. 2 plus negative 2 is 0. So yes, 1 is a 0. 1 is a 0 of this function. And furthermore, I know that x minus 1, that quantity, is a factor. All right. What if I had a divisor that was a complex number? Don't panic, we can do this. We're going to do this just like we did all that other synthetic division that we spent about the last half hour, maybe longer, talking about. So I want to do the same thing. I'm telling you that's the K value, so that is what you are going to leave outside. Set up your bracket. This function is degree 4, check. Do you need a placeholder? I don't know. 4, 3, 2, 1. No, you do not need a placeholder. So just write down all your coefficients. So we have 1, -2, +4, +2, -5. Isn't this going to be a little harder? Just a little. All right, 1 comes straight down. Now we multiply. 1 times 1 plus 2i is 1 plus 2i. And then you remember when we did those complex numbers, we just added real to real, imaginary to imaginary. So -2 plus 1 is -1. And then that plus 2i stays. Now it gets a little harder because when I multiply, I have to be sure that I'm doing my FOIL, right? And when I do that, I should get -1 plus 2i, look how nice this is, minus 2i, look at that, plus 4i squared. Oh, but I squared is just -1, so that's going to simplify, because there's 2 i's, they just drop out. That's going to simplify to -1 minus 4. And that is equal to -5. All right, nice. So I'm going to write -5 up here, because that's what I get when I multiply. Look at that, just a nice regular number, right? So 4 plus -5 is -1. So now all I have to do is multiply 1 plus 2i times -1. So my sign's just reversed. -1 minus 2i. So real part to real part, imaginary part to imaginary part. 2 minus 1 is, or 2 plus -1, same thing, is 1. And then minus 2i. And look at what happens here. So I have 1 plus 2i, that's my divisor that I have to multiply by this guy here, 1 minus 2i. That sounds familiar. You should already know what happens when we multiply that. That's the complex conjugate. All right. So when I multiply that out, I'm gonna, those I terms will just drop out in the middle there again. And I get 1 minus 4i squared. And that is equal to 5 after we get done simplifying it. And look at that, -5 plus 5 is 0. So that tells me this is a 0 of this function. So it has a complex 0. That's fine. That's nothing to be frightened of. So I know that 1 plus 2i is a 0 of this function. So that tells me x minus that exact quantity is a factor. And then here's my answer, so that's my other factor. So it's going to be x to the third, 1x to the third, plus -1 plus 2i x squared, has a complex coefficient there, minus x plus 1 minus 2i is my constant. And then I maybe want to factor this other part here. All right, so I have this complex conjugate theorem, which tells me that if a complex number is a 0 of a function, its complex conjugate is also a 0. So if I have 1 plus 2i, we've already seen, is a 0. Its complex conjugate is 1 minus 2i. That's also going to be a 0 of this function. So I'm going to write 1 minus 2i then, because I know that's another 0. I don't have to divide this whole function. I can just divide what isn't factored yet. So I have, right here, I have x 3, 2, 1. I can go ahead and write these things down for my division problem. So in front of x to the 3, I have 1. And then my next coefficient is going to be minus 1 plus 2i. And then my next coefficient is just going to be negative 1. And then my constant is 1 minus 2i. Don't worry, this isn't going to be as bad as it looks. Look what happens here. That 1 comes straight down. Look what you get. 1 times that divisor, that 1 minus 2i is just 1 minus 2i. When I add these two things, 1 plus negative 1 is 0. 2i plus negative 2i is 0. I get 0. All right. 0 times anything is 0. So here, negative 1 plus 0 is negative 1. Now I need to take that negative 1 and multiply it by 1 minus 2i, and I get negative 1 plus 2i. And when I add that, I get 0, like I was expecting, because that has to be another 0 of the function. So I know that x minus 1 plus 2i is a 0. And I know x minus 1 minus 2i is a 0. I've seen that now. And what is left? If you look here, this is the remainder. This is the constant. That is x. That is x squared. Right? So I have x squared minus 1. And hopefully some bells are going off. I know that's pretty easy to factor. So I get x minus 1 plus 2i, x minus 1 minus 2i. And then to fully factor this last factor, that's the difference of squares. So I know it's going to be x plus 1, x minus 1. And that's it. I'm now fully factored. This really wasn't too bad. I know you were nervous thinking writing these complex numbers down as coefficients, but then look how nicely that all turned out. All right, so let's go ahead and just do one more of these. I see my divisor here is 1 plus 3i. My function that I'm dividing is degree 4. I have 4, 3, 2, 1. I don't need any placeholders. So my first coefficient is 1. My next coefficient is negative 1. My next is positive 6. Then I have 14. And then lastly, negative 20. So 1 comes straight down. Then I multiply 1 plus 3i. I'm left with 3i here. When I do that multiplication, I will end up with negative 9 plus 3i. 6 plus negative 9 is negative 3. Remember that you have to FOIL that out. Let's fix that. There we go. All right, so when you do this bit of multiplication here, you will end up with negative 3 plus 3i minus 9i plus 9i squared. And when you simplify all that, you should get negative 12 minus 6i. So negative 12 minus 6i goes up there. So we get 2 minus 6i. Then you want to multiply again. So 1 plus 3i multiplying by 2 minus 6i. And you get 2, and this works out really nicely, plus 6i minus 6i, and then minus 18i squared. So 2 minus negative 18 is 20. Negative 20 plus 20 is 0. So 1 plus 3i is in fact a 0 of that function.